Hi, Professor. My name is Shuo Zhang, and this is the walkthrough video of the code of my project, which is the application of a hybrid machine learning model for water demand forecasting. Before training the model, exploratory data analysis is applied to find out the features of machine learning. So I just import the original data and then apply the exploratory data analysis, and I plot some features. I plot the relationship of some features with the target variable, which is the water consumption. And then I plot the heat map of data correlation. So by applying the exploratory data analysis, 10 features were selected for machine learning. And the next step is for data pre-processing. So first, I detected some missing value in the data set, and then I replace the missing value by the mean of the column. And for the categorical features, I used one-hot encoder to convert it to numerical features, and then it's the normalization. So for this data set, because the features is with different units, so we got to use the min-max scaler to scaling the data set. And then the data set looks good for training the model. And I have split the target and the features, and then split the train test data set. So in this case, the training set is 20%, and the testing set is 18%. So the next step is for the single model training. So I just use the function from scikit-learn library and call the function. So here is 5 single model, linear regression, support vector machine, random forest, gradient boost regression, and multi-layer neural network. And then I use the metrics from scikit-learn for evaluating the performance of the model. So here is 3 metrics. The first is the mean absolute error, and then mean squared error, and R-squared score. So, and then I just perform the result of the single model. And when we got the result single model, we are going to construct the hybrid model based on the performance of single model. So for the hybrid model construction, the first step is to select the bench models, get into the hybrid model. So there are 3 rules of bench model selecting is applied. The first one is applied on single model without any selection. So we just put all the single model into the bench model benchmark model list, and using the stacking regressor from scikit-learn ensemble library to construct the hybrid model. And the final estimator for here is using the linear regression. And for the second rule is select the single model which has better performance than average. So the first thing is to calculate the average performance, and then I just compare each model in the model directionally with the average performance, and then select the model which is has a better performance than average. So in this case, random forest and gradient boosting regression is selected, and then these two selected single model goes into the benchmark model list, and then apply the stacking regressor. We're going to have the result of the second model, and the third model is quite straightforward. They just remove the best and the worst model, and then linear regression, random forest, and artificial neural network model is selected into the third benchmark model list. And when this three model is built, we're going to compare their performance, and then we use the best rules for the hybrid model construction. And then for selecting the final estimator, so here are 5 final estimator applied. The first one is linear model here, and then I just use the support vector regression, random forest, and gradient boosting, and multi-layer neural network, and then compare the results. Selected the best performance is linear regression. So then we can build our hybrid model for model robustness. So here I build a pipeline, which including the data preprocessing steps, like deal with the missing value scaling and convert the categorical data to numerical, and then apply the hybrid model, which is using the stacking regressor. The estimators is benchmark model list 3, and the final estimator is linear regression. So here is the construction of the hybrid model, and then I apply the model in the new data set and get the R2 scores for the model robustness. So this is all for my code. Thanks for review.